No rot here, but toys, weeds, and trash against the fence. A clean yard, painted fence, and maintained siding. Number 9 goes off. 13 calories per square centimeter. Overpressure, 3.5 pounds per square inch. Time sequence photography shows the results. Destruction on the right from the yard trash which set fire to the fence. On the left, rotted wood in the siding was the ignition point. Sound painted wood and a clean yard allow the center house to survive. The fire hazards in these projects are not unusual either. 6 big American cities were inspected to ensure that representative conditions were tested. Conditions which suggest that a bomb of even this nominal power could start more than 100,000 fires over 25 square miles of urban area. Our next thermal project, run on Shot 10, required a new instrument line east from ground zero, roughly opposite the main blast line, equipped with thermal recording devices and with blast gauges at 0 and 10-foot heights. The first phase, designed to find out how much protection white smoke would give against thermal flash, employed a standard oil fog over a portion of the new line. In theory, this smoke would scatter and reflect fireball heat. This was a small-scale experiment, but evaluations have indicated that attenuation of radiant energy approached 99%. To explain the second phase of the project, employing black smoke, we must go back to Tumbler Snapper. On the low-altitude burst of Tumbler 4, high-speed cameras recorded a phenomenon never noticed before, a shock wave preceding the main shock front. Here it is again. This precursor wave, as it was called, registers on blast line instruments with a pressure time graph of this type, showing a considerable climb and duration before arrival of the main shock front. A normal shock wave with no precursor is quite different, hitting the instruments with an instantaneous pressure jump. The mechanics of precursor development appear to be these. A weapon bursts, and thermal radiation creates an intensely hot ground layer of air, a layer filled with dust from what is called the popcorning of the hot ground. Milliseconds after the thermal flash, the incident shock wave reaches the ground and expands, trailed outward by the usual reflected wave. Then a new wave, the precursor, begins to build out from the base of the incident wave, racing ahead through the heated air layer. An intense dust cloud follows closely, rising initially to about 50 feet and later to several hundred feet. One important effect of the precursor is to lower peak static pressures without a corresponding reduction of dynamic or wind pressures.